I'm ready for you.
Sounds good. Here we go.
Welcome to the Hackaday podcast. My name is Mike Stish. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 101. Somehow today turned into us talking about lasering and milling absolutely everything. Elliot, you were telling me you did a 10-second hack this weekend.
It might have been 10 seconds. It actually started long ago, before Christmas even. Let's see, we had the Hackaday Christmas party, which was online corporate Christmas party where we all just brought stuff to hack on and got on a server together and chewed the fat while we worked on projects. Mine was my mother-in-law gave me a busted old laptop of hers that had a really beautiful big screen on it. And I've always wanted to pull the screen out, buy one of those cheap Chinese HDMI to LVDS converters, plug it in there and find a good use for it. So let's see. So during the Hackaday Christmas party, I was just taking this laptop apart, which was really fun. Actually, I ended up using some of the frame from that. It had a magnesium metal frame in it.
Right, yeah.
And I ended up grinding some of that up and making sparklers for New Year's out of it. Which, if you throw away any laptops with that like super light metal, you owe it to yourself to take a file to it and light up the magnesium shavings. But I digress. My point is that I had this screen on hand. And so like this was, again, like I said, way back before Christmas. I ordered one of those $15 converter things. It finally got here over the weekend. I guess it got here on Friday last week. And I was like, oh, let's see what I can do. It turns out if you want to make a monitor out of something that's basically already a monitor and you buy the right part, you just plug it together and it works.
Yeah, that's nice. Did you have to like solder to ribbon cable or did it all just fit?
You just buy the right one. You look at the model number. I was talking to Roger Chang during the Christmas party about this. When I met him, he was working on a like portable computer that he had built himself out of parts.
The luggable PC, that one?
Yeah, that was awesome, right?
Yeah, that's one of my favorites.
Yeah, and he had done exactly this with the screen on that. And since then, I had been meaning to do it. And here I was with him in the telco, and I was tearing the screen apart. So I was like, how hard is it? And he's like, it's not. You just look at the part number, put that into eBay or Alibaba, and then order the right thing. And so I did. And lo and behold, 3 weeks later, when the parts came, boom, plug it together. And I guess I needed a frame for it. And that was 3 pieces of wood, cut at nice right angles. And I actually fastened it to the wooden frame. This is for my basement wood shop, actually. And so I fastened it to the frame with double-sided sticky tape and hung it up on the wall. Problem solved.
A proper hack.
It's beautiful. And it actually looks totally good. I put it right up on my tool board. So it's like hammer, chisels, like rulers, and then big screen that's connected to a Raspberry Pi.
Yeah. Is it in a separate place from all of your hand planes?
It's right next to them.
What about your rasp collection?
I keep the rasps over in the corner. I don't use them very much.
Well, that's awesome. I mean, I do feel bad, when you have an old computer and you're like, well, man, what are we going to do with this? There are a lot of places that you can donate them to, so that's an option. But when you have one where you the screen is good, but the memory, which is soldered onto it, is shot or some other problem, this is a good workaround. We've seen a lot of people use those LVDS boards for things like taking the brain out of the laptop and putting like a Raspberry Pi in there and then stitching the laptop's own screen into the Raspberry Pi ecosystem.
And now I'm looking at our closet and we have like 6 more busted laptops in there, including a couple of like those ePCs, which have really nice little screens in them. And I'm thinking some kind of portable CyberDeck-like thing. And then we have a big old Asus that must have a 17-inch screen. And I'm like,
wow,
movie shower for my son. I don't know. Like I've got more screens now than I have applications for so many screens, I think, which is a weird position to be in. The amount of effort, you'll spend as much time clicking on Alibaba as you will putting the thing together.
Well, let's start off our hacks today with one that is the holy grail of home circuit board fabrication, I guess, depending on the kind of high-end fabrication tools you have in your home. This is a laser that blasts out high-quality PCBs, and I think For the longest time, people have been trying to figure out how to use a laser cutter to make PCBs that are as good or better than the toner transfer method, and this looks like they've done it. It's actually ablating the copper from the copper-clad boards with the laser itself through something like 20 passes over the copper. It doesn't sound like you have to spray anything on. We've seen before where people are like spraying black spray paint in order to use that as a resistor. I think there might have been somewhere you sprayed it black and then you shot it with a super powerful laser blast, and because it wasn't reflective, you'd be able to blow right through the copper. But this one's more straightforward. I like it that it even goes the extra step on fabrication. Once you've etched the isolation into the circuit board, you can then cover it in UV cured epoxy as the solder mask. And then you can use the laser again to etch out that solder mask where the pads are. And then turn the laser all the way up to 11 and cut right through the board in order to do the board outline.
Yeah, this was terrifying. I saw this hack and I was like, oh man, I have to go check out this laser because I need me one of those. And that's where this becomes a less obvious hack. Like the laser machine in question is a 20-watt fiber laser. It's a super infrared laser, and that's what's doing the action here. You can buy these machines these days for about $1,500 to $2,500. So, it's not an impulse purchase, but that's pretty amazing that you can get a machine that can ablate copper in, a reasonable amount of time for so little money.
Yeah, I predict you're going to have one of these in your basement before long, Elliot.
I will not. I think I would love to. It got me looking for, sometimes you can find on eBay used laser heads, because when they run for a certain number of hours, often companies who use them will sell them. And so they're at like 80% of their rated power, which wouldn't be so bad. And those you can usually get for a song. The question is getting all the optics and the fiber optics that go along with it, and the rest of it is, it's non-trivial, but you could save $1,500, so that's good by me.
What happens when you screw up the coding for your optics and the laser shoots out the side of the machine at 20 watts?
Yeah, so you really don't want to mess around with infrared lasers, and that's where the $1,500 may actually be a bargain. What do I know? Anyway, I'm just astounded by this. I've seen some of the commercial infrared laser PCB etching machines run, and they ablate copper in one pass. And I was talking to the guy who was running one of these at a trade show, and he's like, yeah, it's a 300-watt machine. He's just like, no big deal. And I'm like, yeah, super. All right, my next hack is another machine that I want in my basement. This is Vertical Mill Complete Scrapyard Lathe Build. This is a video by Roland Van Roy. It's a symphony in square cut and tapped thick aluminum plates. It's just beautifully put together. He works it in SketchUp first and then starts building it. But what I love most about this video is just his approach to it. He's just entirely matter of fact, working through all of the design issues and how he solves them, and just putting them together simply. And he doesn't make a big deal out of it. There's no like YouTube flashy presentation or any of that crap. It's just like, here I had to tap these and screw these together. Here I did this. But the whole thing is just littered with awesome tips. My favorite among them, I think, was for drilling holes to mount one piece of metal to another. You could mark them and try to drill them in the right place. His solution is to CA glue, so, super glue the part you want in the location you want. So then it's like held nice and fixed there. Then you drill the tapping holes in it. Then you can knock it off again with he pries it with a screwdriver, because even super glue isn't that super, holding two pieces of metal together. And then he taps the holes, and he's got holes drilled to exactly fit the part that he wanted to fix there. I think it's just a sweet tip.
Yeah, have you watched the ClickSpring videos when he made the clock in the home shop? One of his go-to ways of holding parts onto the mandrels is to CA glue them.
Oh, right.
Yeah, and then he just heats them, and the heat breaks the bond. There was only one time where he mentioned he was too aggressive with the turning of the part on the lathe, and it heated up and broke the glue bond.
Oh,
but Yeah, I've seen a ton of woodworkers that like to use that as well with the activator, and it just
Yeah.
it's like an immediate bond that you can go through the milling process. I've also seen people do it. I think it's with CA glue where you put paper in between them. Wood glue, paper glue, wood, right? It's a sandwich, and then you
Okay.
can break those apart afterwards, and it breaks along the paper, and then you can just sand it off along with the glue.
All right. Yeah, I know a bunch of people who swear by CA glue over tape as a milling surface hold down. So you put the tape
Ah,
on the milling
right.
surface and then you put the CA glue on that and then you glue your thing to the tape. You could peel the tape up off afterwards and then get the glue off the back side of the part. That's pretty cool.
Yeah. I really like Roland's hand-drawn schematics on this one. There's just something really satisfying about looking at them, and I feel like no matter how hard I try, I can never draw this cleanly of a schematic.
One of the things I really loved the most was just his kind of matter-of-fact approach to the whole thing. And he steps you through the entire order of things and why you have to square this part up first, and then you can use that squareness to get squareness here. And he just follows this all through logically. And I love at the end of that where he's like facing the top of his milling surface. And he's like, so then I built myself a fly cutter. And I'm like, yeah, thanks, guy. But you really should also go look at his lathe build, which is the lower half of this mill. This is actually built onto the frame of a lathe, and it's coaxial with it, so he can do kind of joint lathe milling operations with it. But the lathe is actually even more fantastic in a way, and I can't believe we didn't cover that when it came out. I hadn't seen it. These two videos together are an absolute must-watch, and if you're doing any sort of machine building, you will pick up tips left, right, and center.
Oh, Elliot, I never got to go and play laser tag. Did you ever play laser tag?
What? Of course I did.
Yeah, I remember there was a place in town when I was growing up, but for some reason never ended up being a thing. But in the 90s and I guess in the 80s, going into the 90s, the thought of like lasers in your toys was so cool. And I remember they used to sell like home laser kits. I don't think anything stacks up to Assassin's take on laser tag. This is a design for a custom laser tag handgun that comes with a connector on the back of it and a ribbon cable that goes off. And I think you wear the sensor like maybe on the front of you. It works through infrared in order to decide if one of the other laser tag guns has hit you or not. It's based around the ESP32 and it reports back wirelessly to a base station via MQTT. But there's all kinds of things beyond just the like who shot who and the scoreboard that go into this that make it really nice. There's a clickable scroll wheel on the top of the thing that lets you choose the team that you want to be on at the beginning of each game. It lets you set different features of it. So for instance, like how many shots you can have before you reload and how long it takes to reload and any other number of really fun things, all kind of tied up into this one handheld unit and the remote sensor.
This is like the internet of laser tag.
I don't think it's laser either, is it?
Laser tag was never lasers anyway.
Right, it was just
Who are we kidding?
like an infrared flashlight. I like to see all of the iterations that have gone through here, and even in his write-up, Assassin says that I'm putting this down for posterity because I'm about to move on for another project and I don't want to forget about it. It is open source, so if you want to go and set these things up yourself, you certainly can do it. Maybe time to relive my 90s childhood.
I actually had a laser tag set. I had 2 guns and 2 things, and we would play them in break in high school. We would like be running around the deserted hallways on the 4th floor of my high school shooting lasers at each other.
Ah, different times.
Not literally shooting lasers. There are no lasers.
No lasers, right.
Playing laser tag. Playing tag. Yeah, different times indeed. All right, next up is a video from the YouTube channel Breaking Taps run by Zachary Tong. This is micro machining glass with a laser. This is our 3rd laser in a row.
I know it's between machining and lasers all day today.
Micro machining glass with a laser very, very slowly. It uses a process called laser-induced backside wet etching. And if you've never heard of this, don't worry, Zachary hadn't either. In fact, he thought he'd kind of invented this procedure and then went to look it up, and of course it turns out he hadn't. The basic idea here is you put a piece of glass down just on the surface of a fluid, and you shoot a laser through it. The laser passes right through the glass, hits the fluid, and then makes a plasma in the fluid that then etches away the backside of the glass. And so that's laser-induced backside wet etching. In this case, the fluid he's using has a lot of copper sulfide in it, which absorbs the wavelength that he's hitting the laser with. It's actually a really crazy complicated reaction because he has to shoot each point he wants to ablate a few times. And the first time, it actually kind of knocks some of the copper out of solution, and you get a very thin copper layer on the glass. So then the second shot finds the glass with a tiny little bit of copper on the backside of it and then a bubble around it, which allows it to superheat the copper up, which then makes a plasma and then, boom, etches it away. And you might be thinking that there's a thin line between too much explosions underwater on your glass and too little. And of course you'd be right. And he explores all of this in this video. The video also features a super high-speed camera and attempts at capturing this going on in real time. Unfortunately, the laser's going too fast to be hit every frame by the camera, but because it's also so repetitive, he gets a good set of pictures of this going on, and it's really interesting to watch.
See, Elliot, this just cut the cost of your fiber laser in half because you can use it for both.
Right?
Your circuit boards and now your glass etching. And, you already have cupric chloride on hand for etching boards, right?
Of course I do. Yeah, this
no
is
problem.
This is a three-fer.
Throw some slides on there and laser it up.
Yeah, and the real problem here, of course, is that he's using a 50-watt fiber laser. And so you've now just given me the reason to get an even more powerful laser to play with. No, it's a lovely experiment and exploration of a technique I didn't even know about, and the slow motion video just adds to it. One of the coolest parts of this is he's going along there ablating this thing, and I guess it's hot enough that it's melting some of the glass, and he sees this kind of cotton candy-like substance coming up off the top of one of the slides he's etching, and he's like, "What is that?" And he's pulling on it, and he's like, "I think I've literally made fiberglass." Because it's like these tiny, like super thin glass fibers that just get thrown off the top.
But it's like there's a fan on them, right? It must be the steam of the water coming up and pushing those strands away, almost like, when you make cotton candy, there's a centrifugal force, or centripetal, I can never keep those two straight, that makes the wisps in the cotton candy. It's like the same thing is happening here, but I'm guessing it's got to be the boiling of the liquid.
Anyway, I'd never seen Zachary's YouTube channel before, and it's absolutely fantastic. It's full of all of these kind of deep scientific curiosity dives into interesting phenomenon. And he actually just put out another one on slow motion video of him. Now we're back to milling. Slow motion video of him milling aluminum with a single flute cutter. And so a question a lot of people have is, if you only have one cutting flute around the side of the cutter, does it wobble when it cuts the aluminum? Because it's like cutting, not cutting, cutting, not cutting, cutting, not cutting. He ends up using this high-speed video to track the collet of the mill that he's cutting with, and uses ImageJ, which is a neat image analysis tool set, to figure out how quickly this little white part on the top of the chuck goes around, and decides that there's absolutely no slowdown in his case when he's cutting aluminum. If you like this kind of scientific approach to problems, you should definitely check out his channel.
Al Williams wrote an interesting one this week. TabFS makes your browser a file system. It covers a, I guess, still in development suite of software tools that Omar Rizwan is working on, that links your Linux terminal to the tabs in your browser of choice. Chrome works the best, but it does have utility with Firefox and with Safari. I think it has utility with Safari. I might have to check on that one. At any rate, it literally mounts your browser tabs as a file system on your Linux terminal. And it has some extra added hooks in there. So you'll even have a file that is the name of the tab. So you can do some text processing stuff there. I thought it was really interesting because I thought of things that I do often. For instance, you can open links from the command line. And so I'll often make like a text file that has like 20 links in it and then run like a one-liner that'll open a tab for each of those links. And if you have like certain workflows that you like to do, you could almost have like scripted browser-based keychain files that would open everything for you. If you want to go deeper than that, he demonstrates some things like there are some DOM manipulation things that you can do. For instance, you can tell it, hey, change the background colors of the page that's loaded in this tab. I'm not entirely sure what to do with it, but I do find it intriguing and think so. I think there's a lot of potential there.
I use a fairly scriptable browser myself, and so I run scripts all the time because I do a heck of a lot of repetitive web stuff for work at Hackaday. It's all your fault. And and this looks really interesting for that sort of thing, but it makes it even more approachable because it does kind of bring it into this everything's a file Linux paradigm. I love that each tab has a control file attached to it. And so you can say, you know, whatever the title of this tab is, go back or reload or whatever from the command line. Al writes an example in here where it's like echo remove pipe t blah blah browser title Hackaday control. And this lets you do things like wildcards and all sorts of stuff to like manage all your tabs at once or a subset of them at once. It's really kind of an interesting idea.
Yeah, I was sad. I tried to get it up and running, but I'm a little chicken to run it on the browser that I normally use that has like, you know, tokens and stuff that I don't want to be getting out there.
Right.
So I loaded up Chrome in a Docker container, and that worked great. You use like VNC window in your browser to go into the,
God.
you know, to run the Chrome browser in your container, which is awesome. But I just couldn't quite get it to work. So at any rate, I was sad I couldn't get it running. I did find an issue open in their GitHub that had the same problem, and I, you know, said, "Oh, I'm having the same problem as well." I might revisit it at some point, but you know, it's things like I'll be visiting Hackaday.io and I'll see something and be like, "Oh, I should include that in the next newsletter," and then you end up with, you know, 30 links, and you're like, "Oh, I can't remember which ones those are," and then you just want to open them all in their own window. And I think it would be nice for things like this. The other thing that is mentioned, I think Omar mentions it in the write-up, is you can do things like automate the reloading of browser extensions as you're developing them. So I think if you're actually doing browser-based development, this could be incredibly useful for your automated toolchain.
All right, and rounding up what turns out to be 3 YouTube videos for me is it isn't rocket science. Well, maybe it is. This is a new video by Tech Ingredients, and this one is about making your own rocket motors for like model rockets, except these are fairly big. These are of the size that you certainly would need some sort of license to buy, and he's showing you how to make them yourself. I totally love this guy. He approaches this by saying, "Oh, I was wanting to play around with magnetohydrodynamics, but I needed a fast enough moving fluid that could carry charges, and making a fast moving plasma is really hard. But what makes fast moving plasmas? Rocket engines. So here I'm going to make an hour-long video about all of the nitty-gritty of DIY rocket engines." What? But it's an absolutely fantastic video, and it starts off with some stuff that I didn't know, being not a rocket guy, about how nozzles work and some basics physics there. And then it gets into the real nitty-gritty of just how you would build a rocket engine, which is basically just a tube that's capped at one end, filled with explosive, and has a nozzle at the other. Making the mix of chemicals inside there burn at the right rate and stuff is, well, it's chemistry. It's and probably rocket science. He ends up with kind of a special mix here. A lot of people have used a candy rocket engine, which is a sugar and oxidizer mix. The problem with the traditional candy mix is that you have to melt the potassium nitrate or whatever and the sugar together, and they don't melt without adding water and boiling it, and then you have to get rid of all that excess water, and it's a pain in the butt. He substitutes sorbitol, which has a much lower melting temperature, for table sugar. I guess it costs a little bit more, but you don't have to do this whole wetting and then drying out stage. You just mix out 65% oxidant and 35% sorbitol, and you put them in a pan on the stove, and you mix it up, and boom, you've got rocket motor.
I'm glad someone else is doing these chemistry experiments in their basement because I don't really want to try it out.
Fair enough. So then there's a lot more tips and tricks along the way. You can add glycerin to make the mix easier to pour. You can add iron oxide to make it burn faster. Throw in some ammonium perchlorate to slow the reaction down. You can do all of this tweaking to make your rocket mix exactly right for you. And he even goes so far as doping up the fuses that he uses for this by dipping them in contact cement and then rolling this whole thing in flash powder, which of course he makes himself out of a 50-50 mix of aluminum and ammonium perchlorate. This is one of those where if you're into rockets and fireworks and things that go boom, this is all of the science you would need for it, but it's an hour-long video. If you're not into that, there's a second video where he just lights them on fire and you get to see things go fss.
First up on my list of quick hacks is a project by Tweedo in order to work with ESP8266 modules. This is the kind of module that has castellated edges all around it, and if you don't want to solder onto it, how do you tap into it for your development? Well, in this case, you 3D print a socket and you use paperclip wire in order to make a snap fit. Works out for it really well here, and I think any module that has castellated edges could easily be adapted to work with this. Next up, Oriol Ferrier Messia has really done it with the aesthetic of oddball computer displays. This is, at first I said this is going to be straight out of Kubrick, and it kind of is, but then I realized this is David Lynch's Dune, at least the one that's shown on the top of this. It's very organic. The display is like a double widescreen. It's two different modules together. It's about 4 inches tall and I'd say 24 inches wide or 20 inches wide, swooped up with organic curves all in gold with a wonderful keyboard to match. But there are actually several other designs here. I think it shows you that it doesn't have to be intricate to be awesome. These are very simple designs, but they really stand out. And I think that, you'll whenever you see this picture again, you're going to remember this project. And if you can accomplish that in your aesthetics, you've really done something. And finally, a real quickie, what to do with your Kindle Paperwhite. Do you want to use it as an HDMI screen? That might sound like a horrible idea because of the refresh rate, but when Brendan Slight pulled it off, it actually looks pretty good. Cruising around in a browser has a way better refresh rate than you probably have in your mind. So check this one out.
My first quick hack comes from Gigabecquerel, and he's visualizing ionizing radiation with DIY plastic scintillators. Scintillators glow when they're exposed to radiation. Usually, actually, there's one chemical in there that gives off one wavelength and then another that absorbs it and converts it into a wavelength we can see. He makes kind of not the best scintillators in the world in this experiment, but he's just getting started, and you should absolutely check this out. It's pretty amazing that he can make them at all. Next up, 3D printing in 5 axes makes the world flat. This is it's an algorithm for driving 5-axis 3D printing machines. It's a project by Xinyi Xiao and Sanjay Josh. The idea is that instead of putting supports on things, you could tilt using 2 other axes the part so that everything's vertical. The trick is how to make the algorithm that tells you how to drive the machine to do this, and that's what their project is doing. Last up, Tinker's Project's knockoff Kapton nearly syncs DIY Flex PCB project. I love this one. I actually have tried to make DIY Flex PCBs myself using exactly the same method, which is to take copper tape and glue it onto Kapton tape and then toner transfer and etch it away. He finds out a lot of the same stuff that I do, which is that you have to be really gentle with the etching or else you start dissolving the adhesives in between. He also uses a cheap Kapton tape, which causes some problems. but nonetheless gets a really good result. And I think this is exciting because I'd like to see more people making their own DIY flexible circuit boards.
It's time for our can't miss articles of the week. This is long form content written by excellent Hackaday writers. And this week I chose one by Maya Posh called NVMe Blurs the Lines Between Memory and Storage. I think most people by now have seen the little circuit board connectors. They first kind of popped up on laptop motherboards and were used for things like Wi-Fi cards and tiny little hard drives that were actually solid-state drives, now that you mention it. But since then, we've seen them popping up on desktop motherboards as well, and they're kind of becoming the standard. It is pretty easy to throw one of these onto a board. I don't know if you were like me, but I always just kind of thought that these were another version of SATA, the serial ATA that you find on modern drives. But that's not true. It does have the ability to use SATA drives, but it also has the ability to use several different technologies, and one of them is this NVMe, which is non-volatile memory express. It's kind of like storage with one less gatekeeper in the way, where using a SATA drive on one of these connectors means you'd have to convert all of the PCI Express protocol into something that a SATA drive will understand. NVMe breaks that down and just kind of extends the PCI Express onto the memory itself. It is one step away from like directly plugging memory into the processor on the board.
What enables the high speed, at least as far as I understand it, of NVMe is that solid state drives, being basically just a collection of flash memory chips, could actually be read out more in parallel than, say, an old spinning platter disk could. And that's part of what they're taking advantage of here. They're reading from various different banks of flash memory all at the same time. And NVMe just kind of gives you a protocol for your computer to get this kind of parallel read out of the solid state drive. So it's kind of taking advantage of solid state drives' quirks and letting that memory get faster into the CPU.
Maya's got a nice little list of the different standards for those M.2 connectors. I probably should have said that earlier. Sorry about that. Those are the little, 1.5 to 2 inch long connectors that are used for these drives. And they have a little plastic key inside of them. And that can be in different places for different types of technology. Could be PCI Express, USB 2.0, I2C, SATA, SM bus, along with a few others. The interesting thing about it is if you want to use an NVMe drive and it fits in here, all you need on the software side of it is a driver that interfaces with that. And the thing that she goes into that I'd never thought of before is this opens it up for a lot of hacking. It doesn't have to be a piece of memory that's attached to that. You could do a lot of different things. I guess the example that she uses is actually attaching core memory is kind of like the hottest new interface, the hottest new highway attached to kind of the old rad hardened memory option there. But it really does remind me of retro computing when there was like a card edge connector that you could plug like directly into the bus of the processor. Like this is kind of getting people there if you want to take on writing the driver to work with a piece of your own custom hardware.
Yeah, it's funny. We were talking about this when she was talking about her last article, which was on ISA and PCI buses. And we were kind of lamenting the old days where it was easy to do all of this with like 20 megahertz chips and, simple logic. Her take was that NVMe actually did open up these kind of possibilities, although, maybe you want an FPGA on the other end of things to take advantage of the really fast data stream that's coming in and out. Yeah, so I love this article as kind of the follow-on to a modern hackable interface. It's not just ISA cards anymore. All right, my can't miss article this week is Death of the Serial Squid, When Do You Give Up? This is written by Chris Lott about a project of his own that never really made it. It was the serial squid. The idea is really compelling. He was wanting to work on something that required a UART interface in another room and was like, hey, I could hook this up over Ethernet so that I don't physically have to go into that other room with my laptop to hack on this device. That was the germ of a really great idea. And I actually do something like this all the time with an ESP8266 and G-Link. So I can tell you that it's useful. But then he started thinking, well, you could make this device do other things. You could make it be a programmer, and you could make it speak this protocol and that protocol. And he kind of started getting it more spectacular in his mind. And it started doing basically everything that like a bus pirate does. That made him think about how many different connectors he'd need on the end of this thing. And that's where it became a squid, because it had like 10 arms and stretched out to every possible serial protocol you could think of. And that's probably where the project died, because what he did then was realize that he had to write a everything serial to Ethernet protocol, and then had to write the target software to drive this thing on the computers that you're using it on, and probably cross-platform, and oh dear. And it gets worse because he had in the back of his mind, he wanted to make this modular so you could just plug in like different serial interface units. And he kind of really wanted to do that more than he wanted to make the fixed version of it anyway. He says in his article, he just got lost making kind of a 10-headed Swiss Army knife with no clear purpose and super difficult to manufacture and probably too expensive anyway.
I think it's a really difficult problem that almost everyone faces, is like having the tool and then remembering how to use it the next time you pull it out.
Yeah,
and,
right?
I love to watch Alton Brown. He did the Good Eats series, which I always thought was like a hacker's version of being in the kitchen. But he always said like no unitaskers. Like any tool that you have in the kitchen has to have a bunch of different functionality to it. And I think that's where something like this fails, right? Like if it was one thing, like it listens on SPI buses, and it was obvious that you had, 4 pins on that side and an Ethernet plug on the other side, and you maybe wrote, the address that you'd be able to log in on your browser with, then anytime you need to spy on the SPI bus, you would just plug that in and pull it up and listen to it. But this is like one thing to rule them all. So you got to know like what does each thing connect to? What kind of cable do I need for it? What do I need to do on the software side to set it up to, the right speed in order to watch it and know what it is? And I don't know if it was you that said it or Chris that said it, but somebody said this is like a super bus pirate, which I love the bus pirate, but I had the same problem. Like every time I pull it out and do something different, I have to remember the syntax for the scripting language of it.
If you start out with serial, it's really easy. You use a serial terminal, or you use SOCAT for serial over the network or whatever. That part's really easy. And then you want to branch off to SPI. Oh, crap. How do I get SPI over Ethernet? And this starts killing it. And this is what Bus Pirate tried to solve with their own kind of proprietary shortcuts coding language. But I can never remember what any of the settings are. And they're all of these horrible, like N means something and V means something. And I can never remember what that is. I never really made friends with the Bus Pirate myself.
I still use it. I like it. I think it's really versatile. I don't want to make it sound like I think that it did a bad job, because I still have one and I still pull it out. I have to look up the pinout for it every time, and I have a cheat sheet of stuff that I know how to do with it, and half the time it works and half the time it doesn't. But it's still better than any other like multi-tool that I have for looking in on stuff. I think what was the Great FET?
I was gonna say, I think Travis Goodspeed's old GoodFET, and I guess it got taken over by Mike Osman and Great Scott Gadgets, and now it's the Great FET, is exactly that thing. What it does differently than the Bus Pirate, though, is that it moves all of the smarts onto your big computer. So you write the big scripting stuff in Python on your big computer and just kind of shuttle it over there, just kind of puppeting the low-level stuff on the Great FET, GoodFET itself. And I think that's a lot easier to handle, because you can then write a more verbose scripting language on the laptop that's driving everything. So it makes it a lot easier to use than the Bus Pirate was for me anyway.
Yeah, I think last time I looked at it, it was, they're all kind of missing some of the things that you really want. Like they go to a certain point, but I think I wanted like I2C sniffing, and the Great FET didn't have it in the software stack yet. So again, like keeping up with the times on that is difficult, right? Like progress is so fast, and you're like, I need a tool to do this, or I need a tool to do that. I need to do it at this voltage, and I need it to do it at this speed. Even if you come up with one tool, it's going to be good for what, a decade tops, and then you're going to have an upgrade to it.
This is where there's like a bit of just DIY necessary. Like if you want an I2C sniffer, it's not super hard if you know a microcontroller's I2C peripheral hardware to imagine writing one. The problem is that you just got to go do it, right? Like that's actual work, and it's work that you have to do before you can get your real work done. But
I do love when you're testing out a new chip, if you can say, hey, try every address and see if something's connected to it. Like that is so useful.
Oh yeah. Yeah, just an I2C pinger.
Right.
I have a routine for that on basically every microcontroller I've ever used I2C with. So in the end, Chris didn't really learn anything from this failure because it was all kind of stuff that he knew in the beginning, right? It was an undefined scope, and it was scope creep, and it was all of the things that can damn you when you're going down a new project. He kind of laments that a little bit, that maybe he should have known better. But at the same time, he says he learned so much from doing it and from playing around with all these things, and he enjoyed the design process. He used it as an excuse to learn OpenSCAD and KiCad, actually. So like he learned a bunch of useful skills and tools along the way and did some really cool research, and, you know, is certainly a better person for having made this failed project. But, you know, he should have known better. So depending on what your goal is, maybe you want to watch out for feature creep, or maybe you just want to enjoy the ride.
That is all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment in the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us. So if you see something cool or you've done something cool, let us know about it. tips@hackaday.com. And until next time,
keep on hacking. Ooh, that was pretty simultaneous.
For real. I did. I saw it somewhere. Where did I see it?
I did too. Why is it gone? Duh, don't install. Duh, one more time.
Yeah, your YouTube ratio this week is really disappointing, Elliot. I mean, I could say some more stuff, but maybe we should just stop there and move on.
Solid.